So now you've got Java ready, you've written your application, and it's time to essentially prove that your program works properly. And the way to do that, especially in a programming course, is to capture the output and organize that capture in a way that presents it as here's the program executing, and here are, either test values or various runs of the program. For the course that we're doing, you're not going to be submitting the actual executable form of the program, which is the .class file. You'll only be submitting the source code, so that would be the .java file, which are just the instructions, and the output capture document, which is the document which stores, well, the output capture. So as your programs will be getting more advanced, though, as the course goes on, you'll find that you'll be running the program multiple times, especially programs that require input from the user, or programs that may be getting data from a file, and it could be from a few different files. So every time you run the program, it captures it from one file or another. So it could be that the program, when it's running, you're not quite sure what the output will be. And it might be you're capturing 3 or 4 or more runs of the program. So it's very important to produce that output capture and organize it properly. So let's take a look at the whole process. So as I said, we're assuming we've got our program finished, and now it's time to capture the output. Essentially, prove that the program works properly. So what I've got is one of the sample programs from the first exercise set and assignment. I'm calling it Hello World 2. So I'm just going to open it up here, and here's the program. So this one's a little different than the standard Hello World program, because not only does it display the greeting itself is actually being stored in a string. So we're actually storing the message instead of just displaying it immediately using what we refer to as a string literal. So we're actually storing the string somewhere in the program before we display. But here's the statement that displays that greeting. So it's just another systemout.println. We have a blank line that shows up on the screen. So we have a print line with nothing in it. So it's just empty. And what you'll see on the screen is it just goes down to the next line. It's just, in this case, because we're using the print line statements, what you'll see is there'll be a blank line between the greeting and the next thing, which is showing the current date. So this is going to show us the date right now. So whenever I'm running the program. And in this case, I think I'm running it on September 11th, 2021. Not a great day to be doing much official things. I mean, it is September 11th, and a lot of sad memorials around the world. But beside the point, we're doing something interesting, which is Java. So let's compile and run the program, and let's see what we get. So I'm going to open up the output space at the bottom, just so we have a little bit more room. So I'll do a compile, and it is telling me that it compiled properly. So if I take a look at the files, you'll see that we've generated the .class file. So everything looks like it should run. So let's hit the run button, and let's see what happened. So we're running Hello World 2, and there we have it. The message itself, Hello World, and the current date, which is 2021 and 09 for September and September 11th. Now this is really the output. This is the output of the program. No matter how many times I run the program, it's really going to generate the same output. Well, as long as I'm running it on the same day. If I run it tomorrow, it should be September 12th, and so on. So the date would change. But I'm not going to wait until tomorrow just so I can have some different output. We'll modify the program very slightly. But the question is, how do we capture the output and actually put it into a document and store it? Well, in DrJava, there's actually 2 different places that the output actually goes. The first one is the interactions pane right here. The interactions pane is showing you the immediate run of the program right now. It doesn't show you anything that you've done before, but it's showing you the immediate run of the program. It's really the current interactions. So if I compile this program again, you'll see that, well, it's telling me that it's been compiled. And if I run it again, you'll see that the interactions pane is there. But there's no history. It doesn't show me the previous run of the program. That's the interactions pane. Really, the interactions pane is for you to be using the program as you're interacting with it right now. But what about all that historical stuff? Well, that's the console tab right next to it. So if we look at the console tab, there's actually a lot more information. So let me make this window even bigger. You'll see that I've got the previous run of the program. So this is the program where I just ran it like a minute ago. And then this is the one where I ran it right now. I've got really everything that I've done in DrJava since I opened it up. So really everything I do is going to be stored in the console pane. The console pane is where you should be copying all your output from. And this is actually a very useful feature. As I mentioned, with the interaction pane, you only have what you've done right now. So if you wanted to store, let's say you're running the program a few times and you wanted to store the output from the previous runs, you would have to actually capture the output of running the program now, and then you'd have to run the program again and then capture the output again. You'd almost have to feel like you're always capturing the output. But if you're looking at the console tab, you could run the program 2, 3, 4, or a dozen times. And every time you ran the program, and no matter what you did, no matter what the program output, no matter what input you provided, it would all be recorded in the console tab. And that's actually extremely useful. It might have some garbage sometimes. For example, this message right here is just telling you that, this is what the compiler is and you're doing such and such. That is not the output of your program. It's really just the compiler and DrJava telling you something. But you can always delete that part of the output. So this is where we're actually going to be copying the output, is from the console tab. But let me modify the program very slightly here, very slightly. And the reason I'm going to modify it is so that we can see differences in running the program. So right now we've got the local date being used, and let's use the local date time. So instead of just showing me what the calendar date is, which is September 11th, how about showing me the hour, minutes, and seconds, and even milliseconds of running the program? So we can actually see each individual run and be able to differentiate it. So I'm going to change that and say, show me the local date time, not just the local date. All right, so let's compile this program and run it again. Again, I'll just give myself some more room here. We'll run the program again. And you can see that it's given me the time, or the date, September 11th again, but it's given me the time, 1700 hours, 55 minutes, 39 seconds, or 39.464 seconds. So that's 5 o'clock, 5:55. If I run it again, and there's a couple of ways I can run it again. One way I can run it again is hitting the run button, but that will actually blank out the interactions pane just like we had before. And you can see that the time has changed. Instead of 55, it's 56. Let's take a look at the console output. So we've got all the previous runs of the program. I ran the program 3 times when it was just showing me, 2 times where it was just showing me the current date. But now I've got 2 runs of the program where it's showing me the time itself. So I've captured all 4 runs of the program. And I can keep going. I can run this program as many times as I want. Now if I go back over to the interactions pane, we just ran the program by hitting the run button up at the top. But I can also run the program, and I can sort of trick it using the way DrJava runs the program. You can see that it uses its own internal run command. This isn't a Java command. It really has nothing to do with Java. It's just a nice feature within the DrJava integrated development environment. So I can just go down here, hit my cursor, and use the up arrow on the keyboard. Or I could just type in run hello world 2, and I can run it again. So this way, it looks like it's storing multiple runs of the program, but it really isn't. It's just sort of using a built-in feature of DrJava. But if we go over to the console, now you can see that we've run the program 3 times because we have 3 time displays. And you can see that the time is changing. That's actually extremely useful for this example. So now how do we capture this output of the program? How do we capture the output and store it into a document? Well, we're going to keep the program as it is. I think it's a nice little program the way it is. We can see over here in the output, we've got all our hello world 2s. We've got the class file, which is the executable. We've got the Java file, which is the source code. And we've also got the DrJava backup file, the Java tilde file. You can pretty much ignore that one. you're never going to hand that one in as an assignment. You can ignore that file completely. It's just something that DrJava does, but it has nothing to do with what we're doing in Java programming. We're only going to be concerned with the hello world2.java file and the output that we've got on the console, which is all this stuff. So how do we capture the output? Well, the idea is we make sure that our program is finished. So our program is finished. I'm not going to make any modifications to this. I think I like the way it is right now. And I've run it a few different times, as you can see. We've got 3 different time entries here. We've also got it where it only displays the date. So we've got a couple of runs only displaying the date itself. So here's how we capture the output. Using a word processor program like Microsoft Word or Windows WordPad or a Macintosh, I think you can also have Word, Microsoft Word. You can also have TextEdit. That's also a word processor document. We open it up, and I'm going to use WordPad. It's a built-in word processor that comes with Windows. It's much smarter than WordPad, not as smart as Microsoft Word. It's sort of in the middle. It's sort of in the middle in terms of word processors. But it does let us do things like fonts and centering, which is all we really need for the output capture document. So what do we have in the output capture document? Well, let me save it first of all. So I'm going to do a file save as. I'm going to save it as a rich text document. You could save it as one of these other formats, but for the course itself, either saving it as a native Microsoft Word document, which is called a .docx, or as a rich text document, what we call an RTF, a rich text file. So that's what we're going to save it as, and I'm going to put it into my Java Progs folder, and I'll have this as, let's say, Hello World 2 output capture. So you can see it's put the extension RTF at the end. A rich text file format document can store fonts, it can store colors, and all the different types of things you can do with a regular word processor document. So let's zoom in just a little bit here, just so we can get a better view of some of the formatting. So the first thing in the document is, well, let's describe what it is. So this will be, let's see, comp 1130. Let's call it assignment sample. So in your case, it would be something like assignment 1 or assignment 5, but I'll just call it assignment sample. This will be the output capture. So it's the output capture document. Let's see, the author of the document would be me, and my student number is just some made-up number because I don't really have one. There we go. So that's the title of the document. We can center this if we want, which we should. So I'll center it over here. Awesome. So now we're ready to do the output capture itself. So the output capture with multiple runs. So we're going to run the program a few times. Now we've already run it, I think we have, if we go back over here to DrJava, we've got it running twice. So we've got it running once here with the date. We've got it running here with the date. So we've got 2 runs with the standard date, and then we have, I think, 1, 2, 3 with the times. So we've got it as 5 different runs of the program. So let's put over here, so we'll call it run 1. So with only date, run 2 with only date, run 3 with time, run 4 with time, run 5 with time. So these are just headings, really. That's all these are. And you can format these with whatever font you like. I think it's set to Calibri. You can set it to really anything that looks nice. The output capture document is a report. It's proof that the program works right. So you'd better spend some time and actually make it presentable. So Times New Roman. I don't really like that one. But I am going to bold these because I like the fact of bolding the titles for each run of the program. So I'm just highlighting and essentially hitting bold for each one. So we'll do the last one. Oh, excellent. There we go. So now I haven't actually captured the output of the program, but I've got my preparation for doing the copying from DrJava into this document. So let me hit save, just to make sure it is saved. There we go. So let's capture the output of the program. So let's go back over to DrJava, and we've got the first run of the program. The first run is just these 2 lines. Nothing to do with the compiler is using. Now, of course, as your programs are going to be changing, you're going to be writing multiple programs throughout the course, the output will be whatever the output happens to be. And there will also be some user input as well. So the run just won't be just 2 lines of output. The run of the program might be a screen's worth. Well, that's awesome. So you can just highlight it accordingly. Now, if you do highlight it within DrJava, so let's say I've highlighted my output here. Let me highlight it properly. If I right-click on this highlight section, you'll notice that there's no copy. So save copy of console. That saves basically everything. What we want to do is only save the section that we want. We could copy the whole thing and then play around with and edit it, but really if we just copy out what we need, that's perfect. So if you highlight it on the keyboard, if you hit Control-C, or if you're on a Macintosh, it's Command-C on the keyboard, that copies it into the clipboard. You don't see anything going on the screen, but if we go back over here and then we paste it, so if we go over here and paste, you'll see there's my output. So that's the first run of the program. So let me capture the second run of the program. So go down to the next one. Now you'll notice, of course, they're both exactly the same, but that's beside the point. So I'll hit Control-C on the keyboard, come back over here, we're in run 2, and I'll hit Control-V on the keyboard, which is paste. So let's capture run 3. So now we've got it with times. So now we've got this over here. So we'll hit Control-C, we'll move it over here, we'll paste that in. So that was our 1755 time. So now we'll go down to the next one. So here's our next run of the program. Control-C, paste that in, and then we've got our final run of the program. Whoops, let me highlight that properly. Only want to highlight what I want. Copy that, and we'll move it over. All right, so really at this point, let me zoom out just a little bit. We've captured everything for this program. We've got multiple runs. We've got 5 different runs of the program. We've got the heading for our program. I think we're pretty happy. I think it's pretty self-descriptive. We've got a little section here which is describing what we're going to see below. And then I've got all my various multiple runs of the program. Now, there's 2 things that you have to remember. And these are very, very important things. I'm going to make a note of them. If I could spell. Number 1, do not change the output text. This is something special in science, especially in computing science. If we look at this program, let's say we took the first one and we've got hello world, but you'll notice that we've got the space there because we've got that blank print line statement. But let's say we didn't want it there. Let's say, we just didn't like it. So we go back over here to the output capture document and we delete the space. Well, at this point, you're probably going to get 0 on the assignment because you've modified the output. You've told somebody that here's what the output of the program is. But if somebody looks at this program, they're going to see that there's this print line statement. So how is it possible that the output of the program would show the greeting and the date, but not put a space there? That's what you're showing, is that there is no space, but it's in the code. You've modified the output of the program. Essentially, you haven't proven that the program works because you've disconnected the output from the actual program. That really is a mark of 0 on an assignment because who knows what you've done? You might have just typed in this output. Who knows if the program works? So the idea is you copy exactly what the program does, into the output capture document. Now, number 2, you may format the output text. And this is something that you should. You should format it with a non-proportional, monospaced, or fixed-width font. What is a non-proportional, monospaced, fixed-width font? Well, it's a font where all the letters have exactly the same space. Let me show you what I mean by that. So let me type in, let's see, a bunch of I's. So let me put 10 I's in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And let me put 10 M's in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do you see anything strange going on here? Well, the I's definitely take up less space in the sentence than the M's do. Even though there's 10 I's and there's 10 M's, they're really taking up the different amount of space. Well, that's because the font being used here is the Calibri font. So this is Calibri Font. Calibri Font is known as a proportional font or a regular font. It means a letter will only take up the space that it needs and it won't take up anything more. But let's copy this and paste it down here. And what we'll do is we'll change it to a font which is a non-proportional, which means all the characters have the same proportion. So they're not individually proportioned. So this is a non-proportional or monospaced, which means they all have the same space, or fixed width, meaning that the width of each letter is fixed. They all have the same width. There's not that many fonts, well, available in Windows like that. One of the most common ones is Courier New, and the one that has been mentioned in class is Consolus. And there's a few different other ones. You might actually see them as monospace font or terminal font. But let me just talk about these two. How do you know what font is non-proportional or proportional? I couldn't tell you. But once you know the secret of checking, then you're able to check any font that you like. If you like the look of a particular font, you can check to see if it's proportional or non-proportional. So let me adjust this text here, which is still using Calibri. I'm going to change it so that it uses Consolus. So let's scroll down. Here's Consolus. And now if you look at it, the I's and the M's take up the same amount of space. Every letter I is the same exact width as the letter M. Let's change it to another font. Let's try the Courier font. So that was the first one that was mentioned. So let's scroll down to Courier or Courier New. Let's use Courier New. And there's Courier New. So you can see all the letters take up the same amount of space. This is very important when you're copying the output of the program. Because if we go back over here to DrJava, all of this output is using whatever font you've actually told DrJava to use. So if we look at the font that's been set up for all the output, we'll go over here to fonts, you'll see that it's using Consolus in my case. So it could be using monospaced. It could be using Courier New. Those are the best fonts being used for coding, which I'll talk about in just one moment. But this is what the output is like. So if you're putting out the time along with Hello World, like we have here, you'll notice that the 2021 date lines up with the first letters of hello, hell. So that's very important because this is what the program output should look like. So if we go back over here to the output, let's change all the output here, which is currently using the Calibri font. We should change that to use one of the non-proportional fonts. So I'm going to change those all to be using Courier New. So let me delete all these notes because this has nothing to do with the output capture document. So there we go. So I'm going to highlight these and change them to Courier New. You can use any non-proportional font you want, but it's very important to change it to one of these fonts, and the reason is that this is what the program output looks like. It's not using any other type of font. It's a standard fixed width font. It doesn't matter which one it is. It doesn't have to be the same one that you're using when you're coding in DrJava or within any of your Java program, but we expect all the output to be nicely formatted with a non-proportional font. It doesn't matter which one. So we change that because that's how we expect the program output to be. So if you're proving that the program works right, well, you better prove that it looks just right. So there we go. At this point, this output document is set. It's done. I mean, you can play around with it some more. You can put in some bolding there. Let's say you didn't like the fact that this was formatted with a bold. You can change the font if you want. You'd probably italicize it, make it really stand out. But you're not going to do that to the actual output capture. The output capture itself, the only thing you should do to it is change the type of font it is. I mean, you could probably change the size. I don't think the size has anything to do with, spacing or anything like that. So if you wanted to change them all to 9 point, that's perfectly okay. So let's undo that. So we'll save it and close this down. Let's minimize DrJava, and we'll see that we've got the two files that we're actually going to send in. Whoops, let's stop that. So we've got the Hello World 2 output capture. So that's the actual output capture of this. And you've also got the Java program itself. I think that's about it. Now you know how to do the output capture from DrJava. Quick summary: once you finish your program, you capture from the console tab, not the interactions tab, from the console tab. And this will be very important once we start talking about user input, but it'll be from the console tab. And then once you've got it all figured out, let's open up this document. This would be a good basis or a good starting point for all the output capture documents you're going to be doing. So it's got a nice title at the top, describes what it is, describes you. Let me spell my name properly. And I'm missing an A. There we go. And it describes your student number. That's perfectly fine. If you wanted to toss in the date, you could probably do that as well. So it's the date that we did the output capture. But then this section down here is important. So describing the various runs. Here's the output for it. It doesn't mean you always have 5 runs. Depending on the program, you might have 1, you might have 10, or you might have multiple programs that you're capturing the output for. But for all intents and purposes, this is a good output capture document. And I think that's it for right now. Have fun writing your programs and have fun doing the output captures.